Hello everyone, I am Rohan Mode and I am back with a new video surrounding AWS Config. In this video, we will see how evaluation and enforcement of compliance is possible with AWS Config and how will you perform remediation of such identified non-compliant resources with Systems Manager automation. So let's get started. What will you learn today? At first, we will touch base the background and idea behind AWS Config. Further, we will understand how AWS Config works in the backend. What are the administrative features offered by Config? Then we will understand and go through the entire remediation workflow for non-compliant resources identified by Config. And at the last, we will perform a step-by-step implementation with AWS Config and Systems Manager automation. So let's get started. Now, before we dive deep into AWS Config, let's talk a little bit about its background. As we already know that organizations want to provide the best digital experience to their end customers, the requirements keep on changing from time to time. To achieve these, companies are constantly making changes to their application deployments, whether using infrastructure as code or various kind of automation. It really becomes difficult to keep track of compliance in such dynamic environments. So let's take a basic example to understand this. Say that a financial institution is launching a new online banking application to provide customers with easy access to their accounts and transactions. For effective and secure deployments, the institution uses a CI/CD pipeline in order to automate the process of building, testing, and deployment of their application on AWS. However, during the deployment process, a simple misconfiguration occurs and the sensitive customer data is inadvertently exposed to unauthorized users. Therefore, we want the configuration of AWS resources to be continuously assessed, audited, and evaluated against compliance requirements. And any non-compliant resources should be automatically remediated to achieve continuous compliance. This is where AWS Config comes into picture, providing a robust foundation for the enterprise to flag all such misconfigurations, compliant and non-compliant resources in their infrastructure. AWS Config basically records and normalizes any of the configuration changes into a consistent format and provides three basic component features. First, manage, which is basically discovering and recording all the configuration changes, understanding their relationships, and capturing these changes into an S3 bucket into the same region. Second is nothing but evaluate to check resource compliance with either custom or AWS managed config rules before and after the resource has been provisioned into the AWS infrastructure. And the third is nothing but simplify, that is compliance at scale. How we can have the compliance infrastructure or compliance custom rules as well as managed AWS config rules consolidated into one single place, and then we can implement conformance packs, that is nothing but compliance as code solution to scale the compliance verification, evaluation, and remediation in a single place. How does AWS config works in the backend? Let's understand that. Now let's understand AWS config working. Before we dive into technicalities, let's imagine you have a big toy box filled with all sorts of toys, cars, dolls, blocks, and more. And similarly you have various AWS resources into your AWS accounts. Now, AWS config is likely having someone who watches over this toy box and keeps track of every toy or resources inside it. So here's how it works. First, inventory tracking. So AWS config keeps track or list of all the toys or say resources in our context in your toy box or AWS account. It exactly knows what types of toys are there, like cars, dolls, or resources in our context. Second is configuration monitoring. Just like making sure your toys are in the right condition, AWS config checks if the resources are set up correctly and properly. For example, it might see if the cars have wheels and dolls have heads or the blocks are not broken. Similarly, in our context, if the S3 buckets have encryption, if there is termination protection enabled on CloudFormation stacks, etc. Third is change tracking. If someone takes out a toy and puts a new one in your toy box, AWS config notices. Similarly, if a new resource is added or a previous resource or an old resource is terminated, AWS config keeps record of it. It tracks who exactly did what and when. So if someone adds a new toy or car or resources, AWS config keeps a record of it. And fourth, but not the least, compliance checker. Think of AWS config like a toy inspector. It makes sure all the toys or resources follow the rules that you have set properly. For instance, if you have a rule that all cars must have four wheels, AWS config checks to see if any car is missing any wheels. And if you set up in a way, then AWS config will also notify you using AWS SNS simple notification service. Now, the entire diagram explains the same phenomena where a configuration recorder is tracking all the AWS resources into a configuration items. These records are normalized and stored into a consistent format into Amazon S3 bucket where they can be accessed using config APIs, and optionally you can send SNS simple notifications to your email addresses or push notifications. And the second part is you can evaluate the compliance requirements for the recorded configurations against your desired configurations. And this can be visualized and displayed on a single dashboard, providing a single pane of glass for you. Now, let's talk about the administrative features that config provides. At the first, manage multiple accounts. So with config, you can centrally manage multiple accounts and data aggregations for multiple region in a centralized location. Second, you can identify non-compliant resources with AWS config rules and displayed on the dashboards. Third is continuously evaluating configurations with pre-built or custom rules is being provided. Fourth is manage compliance of AWS resource configurations at scale via conformance pack. We'll be publishing another video for the conformance pack on how to set up conformance pack and how to achieve continuous compliance using such conformance pack using AWS RDK, which is Rule Development Kit. That will come into a second video, so stay tuned for it. And the fifth is nothing but continuously view and monitor the resource inventory and configuration history of third-party resources. Now, let's talk about the entire remediation workflow of non-compliant resources which have been identified by AWS config. So remediation of non-compliant resources is important because it helps to ensure that a system or an organization is functioning in accordance with the established standard or regulations. Let's take a basic example to understand this. Say a company has a cloud-based infrastructure on AWS that basically includes multiple Amazon RDS database instances which are used to store sensitive data. The company has a policy that requires all the RDS instances needs to be encrypted using AWS KMS and to have automated backups enabled. However, AWS config flagged that one of the RDS instances is not encrypted with KMS and automated backups are not enabled either. This indicates a non-compliance with the company's security policy and poses a serious security risk. So what would be the remediation in this case? Remediation in this case could involve configuring the RDS instance to use KMS encryption and enable automated backups. So how this can be achieved? This can be achieved in two different ways. So as we have already understood that AWS config records configuration snapshots and those are captured and stored into an S3 bucket. Now, AWS config have two different parts. First, AWS config manage rules, and second, AWS custom rules. So manage rules are basically the rules which are being provided by AWS beforehand, which you can readily utilize for any kind of detections, evaluations, and then further you can add multiple remediation resources for them as well. So remediations can be performed in two different ways. First, either you can set up an Amazon event bridge rule pattern for a custom or a managed config rule so that whenever a resource is turned to non-compliant for a specific rule, an Amazon event bridge rule will trigger a remediation Lambda function. Similarly, this can be achieved using AWS Systems Manager automation. And this is something we are going to take a look into the demo that we are going to see in next few slides. So let's dive deep into demo and get started. The entire demo basically consists of 9 steps. The first step is to enable config recorder. For that, just search for config under the search bar and click on it. Once the config dashboard is open, just click on get started. We are enabling AWS config for Northern Virginia region, and AWS config is region specific. However, you can have multi-region aggregation or multi-region setup for AWS config as well. For this demo purpose, we will be just setting up config for Northern Virginia region. Here now click on get started. We have to leave all the configurations default. For example, recording method, whatever the resources are already been selected, we'll just leave them as it is. Scroll down and under delivery method, just click on, make sure that create a bucket has been already selected, and you have to just provide a bucket name. So we'll just name the bucket as config hyphen bucket hyphen today's date. So 2024-03-38. We have to make sure that the S3 bucket name is unique. And once that is entered, we'll just go and click on next. Now here also under rules, we are not going to select any of the AWS Manager rule as of now. So we'll just scroll down and click, leave everything default and click on next. Now we just have to review everything. As of now, we have left everything default and just added the name of the bucket. The S3 bucket is nothing but the bucket where all the configuration items and configuration records are going to be saved, which are recorded by AWS config. So we'll just click on confirm now. Here you shall see the service link role has been created successfully and S3 bucket has been created successfully. Here you have successfully signed up for AWS config, and this is basically the dashboard where you will find all sorts of information regarding conformance pack, compliance status, config usage metrics, what are the resource inventory. Resource inventory basically shows all the AWS resources that have been deployed into your AWS accounts. Those are up and running. Even if they are in stop state or just idle state, those should be also calculated into the resource inventory part. And on the left side, you can see multiple resources where you can navigate and walk through every single thing. Now in step 2, we'll be creating an IAM role. This IAM role we are going to attach to the EC2 instance that we are going to create in step 3. This IAM role is basically for Amazon EC2 role for Systems Manager. Since Systems Manager do not have permissions by default to access services, we are going to add this role to the EC2 instance to call Systems Manager services on its behalf. So let's search for IAM, click on it. And here on the left panel, click on roles. Here, click on create role. The trusted entity type we are going to leave as AWS service, since we are allowing EC2 to perform actions in this account. Under use case, from the dropdown, we will select EC2. And then we'll just click on next. Here we will search for SSM. And the first role is nothing but the Amazon EC2 role for SSM. We'll see what is the entire policy about. It basically allows all the Systems Manager actions for get, list, and put along with update. This is something which allows EC2 instance to interact with Systems Manager, which will be required for the entire lab. So we'll just add this policy and scroll down and click on next. Here we'll have to provide the name to the role. So we'll provide the name as Amazon EC2 role for SSM. You can update the description, but for the video purposes, I'm just going to leave it default. Scroll down and just click on create role. Now your role has been successfully created. We'll launch a EC2 instance in step 3 and attach this role while launching the EC2 instance. So search for EC2, click on it. Now click on instances And then from the right corner, click on launch instances. Now in the next step, we just have to create an EC2 instance, and we'll attach this Amazon EC2 role for SSM that we just created to that instance, so that the instance should be able to interact with all the systems manager services which are explicitly mentioned into the role. So let's just search for EC2, click on it to open, and then we'll just select instances running. From the right corner, we'll just click on launch instances. Now let's provide the name to the instance as Linux test server. We'll be adding additional tags. So click on add new tag, provide the key as environment and value as dev test. And under resource type, we'll select volumes. Further, we'll scroll down. Under application and OS images, we'll leave Amazon Linux to AMI as default. Under instance type, we'll leave T2 micro, which is free tier eligible. If you do not have a key pair, we'll just make sure that you create a new key pair. Let's provide the name to the key pair as, say, Virginia test key, and make sure you create the key pair. Here you can see Virginia test key has been selected. We'll scroll down, we'll leave everything default and click on advanced details. Remember, we have to still add the IAM role. So here we are going to leave everything default. We are not going to provide any user data. We'll just be providing the IAM role that we just created earlier. So under instance profile, we'll select Amazon EC2 role for SSM. And once everything is added, we'll click on launch instance. Wait for a few moments until your instance is launched. Once the instance is launched, you'll just click on view all instances. Now here you shall see Linux test server has been created and the instance state is running. However, the status check is still initializing. So we'll wait for a few moments. Once the status check is 2 on 2 checks, that means all the processes are completed on the backend and our Linux test server is up and running. So we'll wait for that. And after a while, we'll try to refresh, still initializing. So we'll wait for some more time. Here now you shall see the status check is 2 on 2 checks passed. That means our instance is up and running. So we'll just go and try to connect to this instance. We'll be installing Apache server for this lab on the instance. So we'll just follow those steps. Click on connect. We'll utilize EC2 instance connect to log into the or to SSH to the server. So the username is default EC2-user, and we'll just click on connect. Here we have successfully SSH'd into our EC2 instance using EC2 instance connect. So here we'll be just running few commands to install HTTPD. So sudo yum install HTTPD service. We'll just press yes. Once it completes, we'll enable the HTTPD service. So sudo systemctl enable HTTPD. Once it is enabled, we'll just change the command to start the HTTPD service. And now once it is started, we'll just check the status of the service, if it's up and running or not. Now here you shall see our service is up and running. So now we'll go with the step 5 to set up software inventory in AWS Systems Manager. For that, under services, just search for SSM. Click on it to open. Once you are in Systems Manager console, on the left panel, search for Node Management. Under Node Management, we'll select Fleet Manager. Here you shall see the instance that we have just created is already populated here, since it consists of the SSM agent. And you can see the ping status is online for that SSM agent. So we'll just select the instance, and then under account management, we'll just click on setup inventory. Once you click on that, you can leave the name as default or you can change as per your requirement. Under specified targets, we'll specify a tag. So now you understand why we added an extra tag over there. So we'll just specify the tag as env and the value was dev test. This tagging is always the best way to segregate resources and separate them from one another. So here we have added them properly. Now we'll leave everything else default and just click on setup inventory. Once you have successfully done that, we'll go back to Fleet Manager and select inventory. Once the inventory is created, we'll go under node management and select on inventory. Here we'll scroll down to the end and you shall see our managed instance has been populated over here. We'll just click on instance ID. Once you have clicked on instance ID, you will see the general information about our instance. We'll click on node actions. We'll click on tools. Once you have created that, click here and under node management, click on inventory. Here, scroll down to the bottom and you shall see your managed instance has been populated. Now just click on the instance ID. Here you shall see all the general information about the instance that you have just created earlier. So under general, we'll just under properties, we'll just click on inventory. Here you shall see all the applications that are running on the instance have been already populated. Here we will select for AWS or we'll select for name. Then we'll select for application. And then we'll select for HTTPD and press enter. Once you have created the inventory, we'll go back to inventory page under node management. So we'll click on inventory over here. Once we are on the dashboard for inventory, we'll just scroll down to the end. Here you shall see our managed instance have already been populated. So we'll click on instance ID. Now here you shall see the general information about the instance that we have created earlier. Under properties, we'll click on inventory. Here you shall see all the applications that are running on the instance have already been populated over here. Since we have just installed HTTPD, let's see if we would be able to find HTTPD or not. So name equals to say HTTPD and we'll select that. And here you can see HTTPD service has already been populated, which we just installed. So now since we have now confirmed that, we'll go to the next step. Now in the next step, we'll just add a config rule for blacklist non-compliant applications. For that, search for config under search and click on it. Once you are on the config dashboard, from the left panel under dashboard, click on rules. Here we'll add a rule. So click on add rule. We'll add an AWS manage rule. It's nothing but search for blacklist. And once you see the first rule called EC2 manage instances applications blacklisted. We'll select that. What does that rule say? Checks that none of the specified applications are installed on the instance. Optionally specify the version. Newer versions will not be blacklisted. Optionally specify the platform to apply the rule only to instances running on the platform. So we are going to select HTTPD service so that this instance becomes non-compliant, and then we add a remediation action for that non-compliant resource. So we'll just select the AWS manage rule as of now, and then click on next. Here, leave everything default. Just under parameters for application names, provide the application name as HTTPD. And then under key tags, we'll add the key as environment and value as dev test, so that it identifies the exact resource and applies the rule to it. So we'll review and review everything and then just click on save. Once the rule has been added, we'll wait for the rule to be up and running. Now it's enabled into detective mode. So we'll wait for the rule to show what resources are compliant and what resources are non-compliant based on the number of resources that we have in our AWS account. So let's wait for that and keep refreshing the page. Now you shall see the rule has already detected a compliance status for resources, and it shows that one non-compliant resource is there. So we'll click on the rule and see what kind of resource is non-compliant. So it's our same instance ID, and that resource, the rule shows that it's non-compliant. So what shall be done in such scenario? We'll just click on action and manage remediation now. So we'll be just adding a manual remediation action so that whenever such kind of resources are identified, what should happen after that. So under remediation action, we'll just click on the drop down and select for AWS stop. Just to stop EC2. So here you shall see AWS stop EC2 instance. We'll select that. And under resource ID parameter, we'll just select the instance ID. Once we have done that, we'll click on save changes. Now we have successfully added the remediation role. So once we have added the remediation action, we'll just scroll down and select the resource which is non-compliant as of now. That is nothing but the EC2 instance on which we have the HTTPD service running. So we'll just select that, and now you shall see a remediate button has already populated over here. So we'll just click on remediate. And the assumption is that once we click on remediate, it will run a script in the backend or Lambda function in the backend, which consists of the remediation part or the remediation logic. And once we do that, our resource should be remediated in terms of the remediation action that we have set. It should implement in the backend. So the remediation action here we have set is stop EC2 instance. So we'll just click on remediate and see if the EC2 instance is automatically stopped or not. So now you shall see the status has changed to action execution queued. That means config already detected that there are some changes which are being happening in the backend. So we'll just wait for the status to be changed. Now you shall see the status has changed to action executed successfully, meaning that our remediation rule has successfully implemented. So it should have stopped our EC2 instance. So we'll just quickly go on to EC2 tab and see if the instance has been successfully stopped. So here you can see the Linux test server has already been stopped. So we can state that our remediation action performed successfully. But now you should see that the instance ID or that resource is still non-compliant. Why that might show non-compliant? Because understand that our AWS config rule was not for a stopped EC2 instance, but it was more for the application which is still running on the EC2 instance. Since the application is still on the EC2 instance and in our inventory, until and unless it's there, the compliance status is still going to be non-compliant. So to make sure this compliance status changed to compliant status, will have to go into the EC2 instance and remove the HTTPD service from there. So the next step that we will be performing will be remove Apache server, and then we'll test the compliance status again. So let's just go back to the EC2 instance. Now, since we have stopped the EC2 instance, we'll have to again start the EC2 instance. We'll just click on start instance. We'll wait for the instance to change the state to running, and then status checks to be fulfilled as well, so that everything is up and running in the backend. Now you shall see the status check has been changed to 2 on 2 checks passed, and the instance state is running as well. We'll just quickly SSH into the server by using EC2 Instance Connect. So we'll just click on connect. We'll leave everything default. The username is EC2-user. We'll just click on connect. Now, we'll just quickly check how many HTTPD resources are being running. So we'll just do sudo yum list installed pipe and grep HTTPD. Here you shall see the total number of HTTPD services running in the background. So we'll just remove all the HTTPD services from the backend. Remove HTTPD. Just say yes. Once it has been completed, we'll just perform a quick status check. Sudo system ctl status HTTPD. And here you shall see that unit HTTPD drop service could not be found. That means we have successfully removed the HTTPD service from there. We'll go back on our config dashboard and we'll refresh and see if the resource have changed the compliance status. So we'll go back on rules, select the entire rule, and now we'll just go and do reevaluate. Once we start doing reevaluate, usually it's time based. So AWS config after a specific time will go in and check based on the systems manager inventory whether the resource is having the same service up and running or not, and then it will evaluate the compliance status for that. But now since we have manually initiated the reevaluate status, it will check right away, and in 1 to 2 minutes the status should be changed to compliant. That is something that we are expecting. So we'll wait for a few minutes now because now it still shows non-compliant. We'll wait for a few minutes and then check if the resource status is changed to compliant. Now you shall see the resource has been changed, the compliance status to compliant. It's the same instance ID that we created earlier. So if you go on rules, we can see that the rule is compliant already. And if you go on dashboard, we can see that one compliant rule for one compliant resource is present. So we have successfully implemented the entire step-by-step guide for achieving continuous compliance to SSM automation. Now we have successfully implemented the evaluation and enforcement of compliance with AWS Config and further perform the remediation action for those non-compliant resources using AWS Systems Manager automation. So thanks a lot for listening to my video and stay tuned for part 2. Thank you so much.